Today we are going to learn how to analyze proportions in a graph, and hopefully you start seeing how graphs and tables are related. So before we do that, we are going to define the constant of proportionality. We've already defined this once. So if you've written it down and you have a definition that makes sense to you, you can go ahead and write it now. I'm going to write my definition and then you can copy it. All right, so I've written the equation y equals k times x, where k is the constant of proportionality. And I've explained to you that next year in algebra you will use that equation a lot. And then k, constant of proportionality, is also slope. And then in the table it's the multiplier, so it's what you multiply x by to get y, which is how it ties into the equation. So two conditions for a graph to show direct variation or to show proportionality. The first condition is it passes through the origin. And that is 0.00, so x is 0, y is 0, so it's where the x's meet. And then the second condition is it must be linear, and linear is a straight line. So those are the two conditions that must be met in order for a graph to be proportional: pass through the origin, and linear, which means a straight line. All right, so let's look at our examples. It first says determine whether or not the following graphs represent two quantities that are proportional to each other, and then give reasoning. So here is our first graph, and we're supposed to decide if it's proportional or not. So I'm looking, it's linear, it's a straight line, and it passes through the origin. So the answer to this is yes, and the reasoning is passes through origin. Or if you want to say passes through 0, 0, that's fine too. You don't have to write both of those. Write the one that makes the most sense to you. And then the second condition is it's a straight line or linear. So if you want to use the math word would be linear. All right, so let's look at our next graph. We have this line right here. This is what we're looking at. And so it is a straight line, but it does not pass through the origin. The origin is down here. So the answer to this is no. It does not meet the conditions of proportionality. And the reason is it does not pass through the origin. All right, so let's look at our last example. We have this graph that's the amount of water in each glass. And so I'm supposed to determine if it's proportional or not. And so I'm looking at it, and no, it is not proportional, not linear, or it's not a straight line. And I'm going to say linear. I'm going to use my math word. And it does not pass through the origin. So it is definitely not proportional. All right, so let's look at our next example. It says create a table and a graph for the ratios 2 to 22, 3 to 15, and 1 to 11. Does the table show that the two quantities are proportional to each other? Does the graph show that the two quantities are proportional to each other? So when I have that, like 2 to 22, 2 is my x value and 22 is my y value. So it looks like that. Then my next ratio, 3 is my x, 15 is my y, and then my last one is that. And so the way those values are given to me, they are not in order. So I'm going to rewrite this table, and I'm just going to put these in order. So I have 1, 11, 2, 22, and then 3, 15. And that will make it a little bit easier to graph. And so before I graph it though, let's look at this first part of this question. It says, does the table show that the two quantities are proportional to each other? So I can check that by looking at my K, my constant of proportionality. 1 times 11 is 11. 2 times 11 is 22. But 3 times 11 is not 15. So the table, no, the table is not proportional. And the reason why is I don't have a constant of proportionality. All right, so now I'm going to go ahead and graph these, and you can do the same. Be careful when you do this on your graph. You're going to have to adjust your lines a little bit. So I'll graph mine, and then I will show you what I did. Okay, so on my graph, I went by ones on my x-axis. So here's my x-axis, 1, 2, 3, 4, 5. And then on my y-axis, I went 3, 6, 9, 12, 15, 18, 21. I went by threes so I could get it all to fit on there. And so my graph is going to be 1. It's going to look like that. So my graph is not proportional, and my table is not proportional, and my graph is not proportional because it's not linear. Which I already knew that because my table was not proportional. So these two things are connected. If the table is not proportional, then the graph is not going to be proportional. So that's important. You can't have one of them proportional and one of them not because they're related. So if you can kind of start getting that straight in your mind, that will help you. So I just made myself a little note. The table and the graph are connected. If the table isn't proportional, then the graph is not proportional either. So just start kind of putting that away to remember. Alright, so our last example says graph the following tables and identify if the two quantities are proportional. If they are proportional, identify the constant of proportionality. So I'm going to do my x by 2's. So I have 2, 4, 6, 8, 10, 12, so on. And then my y I can do by 1's. 1, 2, 3, 4, 5. Alright, so my first point is 3, 1. So 3, 1 is going to be right there. Then I have 6, 2. 2, 4, 6, 2. Then I have 9, 3. Then I have 12, 4. Okay, so there's my graph. Alright, and they are proportional. So my graph is linear. It's a straight line. And it passes through the origin. So it's proportional. Which means my table also has to be proportional too. And so I need to figure out what my constant of proportionality is. So 3 times what gives me 1? Well, 3 times 1/3 gives me 1. 6 times 1/3 gives me 2. 9 times 1/3 is 3, and 12 times 1/3 is 4. So my constant of proportionality is 1/3. I think we've answered all parts of the problem. We've graphed, and then it says identify the constant of proportionality, and we've done that. So we are finished with that problem. If you are having questions after doing this lesson, please come see me in the morning.